In this video, we're going to have a look at angles in triangles. A triangle is formed by taking any three non-collinear points, say A, B, and C, and joining the intervals AB, BC, and CA to form a triangle. The intervals are called the sides of the triangle, and the points are called the vertices or singular vertex. This triangle is called triangle ABC. You may already know that the sum of the interior angles of a triangle add to 180 degrees. This can be demonstrated in a few ways. Firstly, pencil pushing. If we take this triangle and I place it on one of the vertices, notice the direction of the pen lid, and if I turn it around the triangle, when I finish, you'll notice that it is done a half a turn or 180 degrees. Another way to demonstrate that the interior angles add to 180 is to simply grab a protractor and measure each of the angles at each vertex, and you'd notice that they all add to 180 degrees. The third way is tearing the corners. If I tear each of the corners off and I get my ruler and I place each of the angles together, you'll notice that they always will form a straight angle. A fourth way of demonstrating this rule is by folding the corners. If I take another triangle, I'll turn it over, and I can fold them all down. So again, you see that the interior angles of the triangle will always form a straight angle. We can also do an algebraic proof. In this diagram, I've drawn interval xy parallel to BC. For ease, I've labelled each of the angles alpha, beta, and gamma. We can see that angle XAB is alternate to angle ABC beta. Therefore, angle XAB equals beta because it's alternate. We can also see that angle YAC is alternate to gamma. Therefore, equals gamma. Therefore, now we have the three angles on a straight angle, alpha plus beta plus gamma being the three initial interior angles equal 180 degrees. Now, we can use that information to find the magnitude of an angle that's missing in a triangle, such as in this example. We know that angle A plus the 20 degrees plus the 70 degrees equals 180 degrees. Therefore, angle A must equal 90 degrees to make that equation true. In this diagram, BC has been extended to produce D. Angle ACD, as marked, is called the exterior angle. Angle BAC and angle ABC, these two angles here, just for ease, we'll label alpha and beta, are called opposite interior angles because they are opposite to the exterior angle at C. The exterior angle of the triangle, angle ACD, is equal to the sum of the opposite interior angles, that is alpha and beta. Now, we can prove this in a number of ways. One way is to draw in a line that's parallel to line AB extending from point C, parallel to AB. Let's label this line CZ. So that is AB is parallel to CZ. Now, we can see that angle ZCD is equal to beta because it's corresponding to angle ABC. And we can also see that angle ACZ is equal to alpha because it's alternate to angle BAC. Therefore, angle ACD, that is the exterior angle of the triangle, equals alpha and beta, which are adjacent angles, which were the opposite interior angles. Now we can use that information in an example such as below. The angle theta is equal to the opposite interior angles, that is 60 degrees plus 80 degrees, being 140 degrees. So the interior angles in a triangle sum to 180 degrees, and the exterior angles are equal to the sum of the opposite interior angles.